So, good afternoon, everyone. Welcome to the lecture 16 of problem solving and computer programming course. In the last lecture, I told you
Sir,
about recursion.
hello, sir.
Yes, yes.
Once again, you explain the recursion. No, sir, I am not
Ah, yeah,
understand.
yeah, yeah,
Started.
yeah, yeah. I'm starting from that only. Okay. In the last class, we discussed about recursion, and I told you the difference between the recursion and the iteration. So before going for a couple of examples that are related to recursion, let us revisit the concept again. Then we are again going to see a couple of examples in which I will tell you how recursion is different from iteration, right? And why recursion is much more beneficial in comparison to iteration, right? So let us see. So recursion, I told you, recursion is repeating a particular, you can say, if a problem is given to you, and if you want to run the programs with different instances, different sets of input, where one input is dependent on another input, then recursion is preferable. Like we see in one of the example, that is factorial of a number. So in order to find a factorial of a number, factorial of that number, in order to determine that, you need its previous factors, right? For example, 5 factorial is dependent on 4 factorial. 4 factorial is dependent on 3 factorial. 3 factorial is dependent on 2 factorial, and 2 factorial is dependent on 1 factorial. 1 factorial is dependent on 0 factorial, right? So our base condition is either 1 or 0. Until unless we reach to 0 or 1, we have to do the process, right? That's why recursion is, you can say, it is also a function, right? But it iterates, okay? Or it calls a particular function repeatedly until unless a condition is satisfied. For example, in the P1, your factorial of a number program, you know that until unless the 0 factorial is reached or 1 factorial is reached, whatever the user has given input, you have to come down to either 0 factorial or 1 factorial. Then you have to do the reverse process again, right? That's why a recursive function is a function that calls itself. Just like somebody is calling someone, okay, two in your class, you have two friends, both friends are having same name, right? So whenever you are calling, so there is a confusion, right? Similarly, in the recursive function, what we are doing, the function calls itself, right? For example, I'll tell the person's name is X, I will tell X in class. Then X refers to two different people because two different people are having same name, right? So there is a confusion. It creates a confusion, right? Similarly, in this case, what happened? A function is calling itself, but the way it is calling itself is different. For example, in the first case, it is calling for 5 factorial, but whenever it is calling itself again, it is not calling for 5 factorial, it is calling for 4 factorial. Again, it is calling itself for 3 factorial. Again, it is calling itself for 2 factorial, 1 factorial, and 0 factorial, like that, right? So this may be done directly or it may be done indirectly. But you have to ensure that in each and every case, you are giving a different set of input. And generally, first one is a complex one, but as you go on, this is a simpler one, right? So a recursive function is called to solve a problem. So if a big problem is given to you, you can solve that problem by go on its previous steps. Like in mathematics, you have seen, if you go for n plus 1 iteration, you require the result of nth iteration. If you give nth iteration, you will get n plus 1 iteration. If you give input n plus 1 iteration, then you will get for n plus 2 iteration. So one further step depends upon what is the result of the current step, right? Similarly, here if you see, the function means the recursive function knows how to solve only the simplest cases. You know what is the base condition. Base condition means in the Fibonacci series, you know 0 factorial is 1, okay, or 1 factorial is 1. which we call as a base case or simplest case. But if anybody will ask what is 5 factorial, you do not know. You have to solve it. Okay. If you know the complete history, then that is of no use. If any factorial, if you give input and there is a lookup table kind of thing, lookup table means you know the answer, then you can immediately return. But here the question is not that. For each and every problem, you have some knowledge. Like 0 factorial and 1 factorial, you know. But other factorial, you do not know. But you can achieve other factorial by the help of 0 factorial and 1 factorial. Okay. So base condition is required in the case of recursion. On any problem you pick, go for Fibonacci series. In the Fibonacci series also, first few input you should know. Without first two input, it is not possible to go for the third input. Okay. Any case, like I will tell you, you will be promoted to second semester if this condition is satisfied. So your second semester is dependent on the result of the first semester. Right? So some relation should be there, right? And suppose in the campus placement case, okay, let's say you are in the 7th semester. We have the first semester to 6th semester. Okay, so I will put some condition. Okay, based upon that, I will decide whether you will go for 7th semester or not. For 7th semester result depends upon the 6th semester, whether you have cleared out all the papers or not. 6th is dependent on 5th, 5th is dependent on 4th, 4th is dependent on 3rd, 3rd is dependent on 2nd, 2nd is dependent on 1, which we call as prerequisites. If prerequisites are there, then only you can reach the 7th semester. So assume that you have the data of the first semester. I am asking the data for the 7th semester. So what you will do? You will say, sir, 7th semester is dependent. 7th semester is dependent on the 6th semester. So let us go to 6th. 6th semester is again dependent on the 5th semester. Let us go to 5th. 5th semester is dependent on 4th semester. We will go 4th. 4th is dependent on 3. We will go to 3. 3 is dependent on 2. 2 is dependent on 1. So finally, whenever we will reach to 1, we will say, sir, I know the details of 1. So I can solve 1 and I can go to 2. Okay. Initially, I asked for the 7, but you came 7, 6, 5, 4, 3, 2, 1. 1 is your base condition. And once base conditions result, you know, right? So by using that, you can go for the second semester. Once you collect the result of second, you can go for third. Third result, you combine, go for 5th, 6th, and 7th. 7th, finally, you have to return it. Right? So for each and every problem which you want to solve through recursion, so make sure that you know the base cases. Without base cases, it is not possible. Right? So if the function is called with a base case, the function simply returns a result. Base case is just like a fundamental language. If you know that fundamental language, that course you can opt. Okay? If you do not have fundamental knowledge, that subject you cannot take. Something like that. So any problem, you should have some result of the base cases. So by looking into that, you can refer other cases, right? And that is a simple case or the base case we say, right? For each and every problem, let it be Fibonacci series or factorial of a number, or there is another problem called Tower of Hanoi, right? TOH problem. Lot of problems are there. And most probably in any competitive exam, you are going to get one question from the recursion. Okay. So now, eventually terminate. So whenever you are calling a particular problem or solving a particular problem, definitely after some time it will terminate, right? So when it will terminate? When you reach to the base condition. Okay. Unless you reach to the base condition, there is no solution. So you have to reach to the base condition. By reaching to the base condition, that's why each time the function calls itself with a slightly simpler version. So if I'll ask you 5 factorial, then you will ask me what is 4 factorial. So obviously 4 factorial is simpler than 5 factorial. Number of calculation is more. Okay, one calculation is more in the case of 5 factorial. Then you are asking 4 factorial, then I'll say, you tell me about 3 factorial. 3 factorial, then you will say again 2 factorial. 2 factorial, then 1 factorial, or you can say 0 factorial as well. So in each and every step, you are going for a smaller version or a simpler version. But the original problem is complex one. But by applying recursion, as you go progress, your problem will become more simpler. Okay. So every step, whatever you are proceeding, that is a simpler version of the original problem. So the sequence of smaller and smaller problems must eventually converge on the base case. Converge means you should reach to the base case because you know the result of the base case. Okay, so it must converge on the base case. I will tell you in the Fibonacci series what is the converge, right? And what is the prediction, what is the golden ratio. Okay, so at that point means when you reach to the base case, the function recognizes the base case and returns a result. When you reach to 0 factorial, you know 0 factorial is 1. When you reach to 1 factorial, you know. But if somebody asks 2 factorial, you will say, no, I do not know. You tell me about 1 factorial. 1 factorial is 1, so 2 into 1 is 2 in the case of 2 factorial. Okay? Except the base cases, all other cases you have to derive by the help of recursion. Right? And as you know the base case, whenever you reach to the base case, you can return the result to the previous copy of the function. So you are generating multiple copies. You are generating multiple copies of the same program. But the input to each and every function is different. Like one case it is 5 factorial, another case it is 4, another case 3, another case 2, another case 1, another case with 0 factorial. Right? So input varies with respect to the, you can say, with respect to the smaller input, then functions may be the same function we are calling with different inputs. So see here, the number. Generally, we are calculating factorial of a number through this recursion process. You can also do through iteration, but generally we are doing through the recursion. Okay. So the factorial always we are finding for non-negative number, right? The non-negative number n. The factorial of a non-negative integer n, we are writing by n factorial, right? And how we are determining n factorial? N factorial is nothing but n into n minus 1 into n minus 2 into n minus 3. Like that, you will reach to 1. The last one is 1. Right? So, based upon the input, based upon the value of n, you have to decide how you are going to solve the factorial of a number. Right? So, you have two solutions to factorial of a number. One is through iteration, another is through recursion. Okay. So like here you can see 0 factorial is 1, 1 factorial is 1. So if somebody will ask 5 factorial, so you will say 5 into 5 minus 1. Okay, you can write if you put the 5 value here. So what you can say? So in the 5 factorial case, so what we can say? If you will put n value is 5, you will say 5, 5 minus 1, okay, 5 minus 2, okay, 5 minus 3, 5 minus 4, and finally the value is 1. Right? The 5 minus 5 is 1. Until unless you reach to 1, you have to find the solution. Similarly, 6 case, you can say 6 into 6 minus 1, 6 minus 2, 6 minus 4, 6 minus 5 into 1. Right? Or in this case, you are getting 5 minus 4 is 1. So last term is 5 minus 4. Right? Or if you are going for 0 factorial, then you go for 5 minus 5. Right? So in the 5 case, you are getting 5, 4, 3, 2, 1. Or you can go for 0 factorial also, which will give you another 1. So what is the resultant? The resultant you are getting is 120. Right? But in order to find 5 factorial, you have to determine its previous factorials. That is the objective of recursion. Right? Now, let us go for the first solution. First solution is iteration. Iteration means non-recursive. Non-recursive means there is no smaller version, there is no larger version. Each and every persons are treated equally. Right? So the factorial of an integer, that is a number, greater than or equal to 0 can be calculated iteratively by using the following statements. What we did here, you have to ask what is the number. You prompt the user to tell the number. Suppose the user is giving the number as 5, as we discussed in the previous slide. Factorial is equal to 1. Okay, let me take a factorial variable. Okay, I am writing factorial. Okay, factorial is equal to 1. Right? For int, counter is equal to number. What is the number? Number is 5. User has given input 5. Counter, okay, is the number. So what is the counter value now? The counter value is now 5. You initialize counter value as 5. Then what you are writing? Counter is greater than 1. So counter value is 5. So 5 is greater than equal to 1 is true. So we will come inside. What you have written? You have used a shorthand operator. Factorial is equal to factorial into counter. Factorial is equal to factorial into counter. Okay. So what is the factorial value? Factorial value is 1. Right. Counter value is 1. 1 and 5 I will multiply and I will replace with factorial. Right. This is equivalent to, if you see, factorial is equal to factorial. Okay, factorial into counter, right? Into counter. Okay, so what is the factorial value? 1. Counter value 5. 1 into 5. So I am getting the answer is 5. Right? In the next iteration, the counter value will be decremented. What is the counter value? If you decrement it, 5 will reduce to 4. Right? Then what I will do again? Factorial is equal to factorial into counter. Right? Factorial into counter is 5 into 20. That will be stored here. Right? Similarly, you will process this one. You will go on process until unless this condition is not satisfied. That is, counter is greater than equal to 1 is not satisfied. Okay. So in this manner you can solve. Okay. Next is a recursive definition. This is called iteration. Okay. But we are not talking about iteration. We are talking about recursion. Recursion is saying if a large problem is given to you, you have to go on iterating. So in each and every case, you are getting a simple, right? The way you are increasing the number of level, you are going to go for a simpler version. So a recursive definition of the factorial function is arrived by observing the algebraic relationship. How? You can see here, if you want to go for a particular value's factorial, then you have to calculate n into n minus 1 factorial, right? Like 5 factorial, you can represent by 5 into 4 minus 1, 5 minus 1 factorial. Okay. So 5 factorial raised to 5 into 4 factorial, right? Again, 4 factorial is nothing but 4 into 3 factorial. Again, 3 is nothing but 3 into 2 factorial. Okay. Then 2 factorial, 1 factorial. Let your base condition is 1 factorial, not 0 factorial. Then you are getting the value as 1. So once you solve this one, you have to backtrack. Backtrack means 2 into 1 is 2. So your answer is 2 here. Then you are putting 2 here. You are getting 6. Right? Again, you are putting here the 6 value. You are getting 24. Right? Like that, it will proceed. Right? So in this way, you have to calculate. Is it okay? So you can see here 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. 5 factorial you can take separate 5 and 4 3 t1 and you can say 5 factorial is nothing but 5 into 4 factorial. So in this way you can solve a problem in the recursion. So what you are doing? You have a big problem, right? That is 5 factorial. You are solving using 4 factorial. 4 factorial you are solving as 3 factorial. That is recursion. But in iteration case we are not doing that. Iteration case we are taking a counter. The counter is initially 5. So you are calling the same statement with different value. Here you are calling the same function multiple times. Try to understand. You are calling the same function repeatedly with different input. Okay. So recursion is much more useful than the iteration, right? So this process you can see. 5 factorial, you are calculated 5 into 4 factorial. 4 factorial is 4 into 3 factorial. 3 factorial is 3 into 2 factorial. 2 factorial is 2 into 1 factorial. And 1 factorial is 1. So this is the call. So once you reach to the base condition, what you have to do? You have to again solve recursively. Or you have to again solve, once you find the result of the base cases, you will solve the problem and reach to the top level. That means, see here, 2 into 1, okay, you are getting 2, then you are putting 2 here, you are getting 6, you are putting 6 here, you are getting 24, you are putting 24 here, you are getting 1. So see the process. One is you are coming from a big problem to the small problem because you have solution to the small problem. Again, you are moving from the small problem to the big problem. Right? This is the recursive calculus evaluation for the factorial of 5. Right? Now, the recursive function factorial first determine whether the terminating condition is true. Right? Sometimes the condition, if a user is given the value 0, then it returns 1. If the value user is given 1, then will return 1. If the user is giving greater than 1, then only we proceed. Like that, you can put condition as and when required. If less than or equal to 1, the factorial returns 1. If it is a negative number, then you will warn the user that you have entered a negative number. And as for the factorial, you have to enter a non-negative number. Okay. So the 1. No further recursion is necessary and the function terminates here. Or 0. But less equal to means negative number is also coming. You have to be good. If the number is greater than 1, then recursive multiples, right? Function then. So you evaluate the factorial number you have entered. We are calculating number minus 1. In our first recursive call. In recursive call, I go for number minus 2, number minus 3, number minus 4, like that. Or the previous number minus 1 always, right? Which is slightly a simpler problem than the original calculation factorial of number. Obviously. Yes, hello.
Sir, voice is breaking, sir.
Is it breaking for all? Please confirm.
Yes, sir.
Yes,
Voice
sir.
is breaking, sir.
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Now it is clear. Now it is clear. Now it is
No,
clear.
sir. Yes, sir.
Please again repeat this slide, sir.
Okay, that whenever you are giving a input, the number, right? You have to check whether the number is less than equal to 1 or the number is greater than 1. If less than equal to 1 means if the case is 0 or 1, okay, then what you can say? The output is 1 because 1 factorial is 1, 0 factorial is also 1. But if a negative number is given as input, then you have to warn the user that you have entered a negative number. Please enter a non-negative number. Given input greater than equal to 1. Sorry, greater than 1, not greater than equal to, greater than 1. Then what you have to do? You have to call the recursive procedure in which whatever number user is given input, you have to take that number minus 1. Okay. In the next recursive call, you have to take the previous number minus 1 or the original number minus 2. In the next call, again previous number minus 1 or main number minus 3. In this way, you go on iterating, okay, and as you progress the recursive call, you are getting a simpler problem than the previous one. Okay, in this way, you are going to calculate the factorial of a number. So this is the code you can see. So here, what I am doing, I have taken a function. The function name is factorial. Okay. The return type is long, unsigned long. Whatever this function is taking, that is also unsigned long. You can take long also or a integer. Okay. You can take as means it is a, if you write long, then you can enter a very big number also. Right. So function prototype is done here. But execution will start from the main function. Right. What we have written here? We have written count to 0. Let us take a variable counter. So counter is equal to 0. Right. And 0 is less than equal to 10. This condition is satisfied. If the condition is satisfied, you have to go inside the for loop. What we have mentioned, Cout set W2. This is first time you are seeing set W. Stands for set width. Set width 2 means the width of the number is 2 only. If you write set width 5, then 5 is the width of the number. Means if you write a digit number, it will come like this. If you input a 3-digit number, you are going to get this. If you write 5, but here we have written 2, right? Then it will print counter. What is the counter value? Counter value is 0, so it is going to print 0. And there is a factorial symbol equal to. This is written in the double quote. The same thing will come. Counter. So you have define that function here, declare the function here, that is nothing but the function prototype. And what is the counter value? The counter value is 0. If the counter value is 0, this value will reach to this particular number, which is a unsigned long. Then we are checking the number is 0, so 0 less than equal to 1. It is true. As it is true, it is returning 1. So it is going to print 0 factorial is equal to 1. Right? Now you have written plus plus counter. So counter value is now increased to 1. Then if you come inside, it is again set with. What is counter? Counter value is now 1. 1 factorial is equal to, it is again calling that function with different value. Sorry, the value is 1 here. Now the counter value is 1. So it is giving 1 to this particular number. So it is again checking 1 is less than equal to 1. Yes, 1 is less than equal to 1. So again it is returning 1. So you are getting 1. Now plus plus counter, the value is increased to 2. Counter value is increased to 2. Then set width of 2, that is 2. It will come here. I am writing here 2 factorial is equal to, it is calling the same function with another input, that is 2. Number 2 you are giving. So number less than equal to 1 is not satisfied. As number less than 1 is not satisfied, you are going for else part. In a number into factorial of number minus 1. What is the number? The number is nothing but 2. So it is saying 2 into factorial of factorial. Okay, number minus 1. What is number minus 1? Factorial of 1. So what it is doing, it is again called. Okay, if you see the second part with input 1. Okay, so if you will call with input 1, what it will print? Number is less than equal to 1, so it will return 1. So it is calculating 2 into 1. So finally it is getting 2. Now let us see another case so that it will be more clear. Let us see the counter is now 3. So it will show 3 factorial is equal to, then it is calling the counter value is 3. It is calling factorial of 3. So it is coming here as a number. So 3 not less than equal to 1. So it will call this one. So it is saying number into, number means, okay, factorial, okay, factorial, okay, number minus 1. What is number minus 1? 3 minus 1. Factorial of 2. So this function is again calling the same function. means this factorial of 2 is again calling it. Whenever you are calling the function, it is not less than equal to 1. So again it is calculating, for this it is calculating 2, okay, factorial of 2 minus 1. It is calling the same function. So we are calculating factorial of 2 minus 1. 2 minus 1 is 1. So this condition is satisfied. 1 is less than equal to 1 is satisfied. What it is returning? It is returning 1. So this value is now 2 into 1. So once you solve this sub problem, you can solve 3 factorial. Once you get, you can calculate here 3 into 2, that is equal to 6. So you can say 3 factorial is 6. So in this manner, you can solve the recursive evaluation of 5 factorial, right? Now come to the next case, that is called as your Fibonacci series. Fibonacci series begins with 0 and has the property that each subsequent Fibonacci number is the sum of the previous two Fibonacci number. What is the meaning? First two value is given to you, which is called as simplest case or base case. Once you find the first two value, it is given, then you can determine the third value. How you can determine the third value? Because third value is the sum of two values. This value is nothing but 0 plus 1. Similarly, the next value, that is 2, is dependent on which one? 1 and 1. Okay. 3 is dependent on 1 and 2. Okay. 5 and so on. Right. So a value is dependent on its previous value. Right. And the ratio of successive Fibonacci number. It is a very interesting part. The ratio of successive Fibonacci number. That means 21 divided by 13, or let it be 13 divided by 8, or you go for 8 divided by 5. That converges on a constant value of 1.618. If you go on iterating this thing or go on calculating this one, after some time you will see the difference. Okay, the ratio between two Fibonacci number is 1.618. You can calculate now also. If you calculate, you are going to get close to 1.6. 1.6, it may be a little bit more from 1.6, but the value is more or less, it is 1.6 only. But after some time, the constant value is 1.618. 2. Frequently occur in nature and has been called as the golden ratio or golden mean. So this is called as your golden ratio or golden mean because the ratio of successive Fibonacci number is 1.618. Right? You check it once. Okay? Using calculator, you can check this thing. Right? So the Fibonacci, how we are going to define? First, you have to mention Fibonacci of 0. Fibonacci of 0 is 0. Fibonacci and Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. For and this Fibonacci is f. So I'll tell you determine f of 3. So what you will say? F of 3 is nothing but f of plus f of 1. True or not? To put here 3 value, it is nothing but 2 and it is 1. Okay. If you want to solve 2, then this value is 2 minus 1 is 1. 2 minus 2 is 0. Right? And you know that that is f of 1 and f of 0. F of 1, f of 0. And f of 1 in decomposition. So f of 1 value is your 1. F of 0 value is 0. F of 1 value is 1. Or the simplest case, you have solution. But you have solution for all the cases. Right? So once you solve this base case, then you can solve the above cases. Like in this case, f of 1 is now 1, f of 0 is 0. So you can sum these two. That is nothing but f of 2. That is 1. Once you solve f of 2 and f of 1, then you can solve f of 3. That is 1 plus So you see in the Fibonacci series that is 0, 1, next one is 1, next one is 1 plus 2. Okay. Similarly, if you calculate for f of 4, let me write here f of 4. But your f of 3 plus f of 2, right? F of 3 is nothing but f of 2 plus f of 1, right? F of 1 plus f of 0. Okay, and f of 2 is nothing but your f of 1 plus f of 0. F of 0 is 0, f of 1 is 1. This is 0, this is 1. This is 1. So what you can say, 1 plus 1, it is 1. So 1 plus 1, it is 2. Okay, 1 plus 0, it is 1. 2 plus 1, it is 3. So you see in the Fibonacci series 0, 1 plus 1, 2, 2 plus 1, 3. Okay, so f of 4 you are going to get 3. So in this way you can solve the Fibonacci series, right? So you can see execution starts from main function. Prior to the main function, we have written the function, and the function name is Fibonacci, which takes the unsigned long, or you take a long only, or you take an integer. Okay, then inside the main function, I have initialized the counter value as 0. Counter is 0 now. Okay, 0 is less than or equal to 10, so it is coming inside. So what it is saying? See out Fibonacci. The counter is 0. So it will print Fibonacci within bracket 0 is equal to Fibonacci of counter. So 0, it will call Fibonacci of 0. So whenever it will call with the input 0, okay, so it will come here. The number value is 0. So we have written if number is equal to 0 or number is equal to 1, then return the number. Because you know that f of 0 is equal to 0 and f of 1 is equal to 1. But if the value is not 0, 1, then you have to apply the recursion, that is Fibonacci of number minus 1 and minus 2. Okay, in the next iteration you can see the counter value is increased to 1 and it will return 1. Then the value is increased to 2. 2 case, this number case will not satisfy. Number is not 0, not 1. So you have to go for this recursion step. You have to go on iterating until unless you reach to the base condition. That base condition is f of 0 and f of 1 respectively. So in this way you can apply to the problem where a bigger problem can be solved using the smaller problems, right? This is the case. If you want to find Fibonacci of 3, then that depends upon Fibonacci of 2 plus 1. And Fibonacci of 1 is the base condition, that's why you are returning 1. Fibonacci of 2 is nothing but Fibonacci of 1 plus Fibonacci of 0. Okay, and Fibonacci of 1 is a base condition, so you now return it. The base condition, that's why you are returning 0. In this way, you can solve the Fibonacci of 3. Right? Like that, you can practice for others also. Now, very much important, any interview also you appear, they are asking the question, what is the difference between recursion and iteration? Okay, although you know that, just I am telling you, iteration and recursion are based on a control statement. Either it is ranging from 1 to 10, or you are calculating 5 factorial, or Fibonacci of 10. There is a controlling factor. Whether base condition is the control factor, or whenever you are starting from a beginning, also you can put some control factor. Okay. So iteration uses a repetition structure. It is repeating with different input. But recursion uses a selection structure. It is applying a selection structure. 3. 5 factorial means it will choose 4 factorial. Or Fibonacci of 3. Fibonacci of 1. Okay. So recursion has negative. In every case, there is a positive negative. I am not saying, but each and every one is having own advantages and disadvantages. But the negative in this case we are getting, it invokes the mechanism and consequently the override of the impulse. as you are calling the same function, okay, repeatedly, that may result overhead. But iteration is also having its disadvantage, right? Going for a simpler version to a larger one, a larger version to a simpler one. So this can be expensive in both processor time and memory space, because you have to keep, in order to calculate Fibonacci of 10, you have to keep 9 and 8. 9 case 8 and 7, 8 case 7 and 6. So everything you have to maintain. So memory space is also required more and processing time is also more. But for the larger problem, it is better to go for recursion, right? Because sometimes we have solution for the smaller data, solution for the larger data. In that case, recursion is preferable, right? So the couple of assignments you try to solve. I will tell you a couple of assignments. Try to write the code for this one. The first assignment is you have to write a function. The function name is int to double. Okay, int to double. As the name suggests, you have to give a integer number and convert it to double number. Means if you are giving 2, it is nothing but 2.0, right? So this function int to double, that takes an integer argument or a number and returns at double precision, or you can say floating point rate. 05 is 5.0. Okay, and what you have to do in this program, write a declaration. Declaration is above the main function for each of the following. First one, integer count should be, and you maintain the register and initialize it with 0. The count value is 0 and you go on increasing that counter. Next, double precision floating point variables. Last value, variable last value you have taken for this one. In the value between calls to that function in which it is defined. When you are calling a function, okay, you have defined a function definition is there. That you have to record in the last value, right? So these two tasks you have to do, right? How to convert the int to double. The next assignment, find the errors in each of the following program segment, right? And explain how the errors can be corrected. So you can see here we have two functions. One is g function, another is h function. Inside g function, you have defined h function. Okay. So there is a cout statement inside h. So determine what is the error. Okay. Similarly, in the second case, you have a function with two variable of integer type, that is x and y, right? And you have declared a variable inside that function, that is result, int result. Okay, and you are calculating result is equal to x plus y. So there is a small error in this code, you have to correct it, right? Assignment. Write a complete program that prompts the user for the radius of a sphere. So you have to write a cout statement which will prompt the user, ask the user, enter the radius of a sphere. Once the user has given input, the radius, what you have to do? You have to calculate and print the volume of that sphere. Okay? Use an inline function. In the last class, we have discussed about the entire code will come to the main block. From main, you should not go to that particular function. So use an inline function, sphere, that returns of the following expression. That is 4 by 3 pi r cube. 4 by 3, pi value is 3.1414159 and radius cube, that you are writing pow within bracket radius comma 3, right? But you have to give only radius as input and calculate the volume. And that function, whatever you are defined to calculate the volume, the name of the function should be sphere volume and it should be an inline function. Fourth assignment, okay? You have to include the appropriate header file before using these functions. Okay, that is the first thing. Next one is you have to calculate what is the value. X is equal to FABS 7.5. X is equal to floor ABS 0.0. X is equal to seal 0.0. X is equal to FABS minus 6.4. X is equal to seal minus 6.4. X is equal to seal minus FFs minus 8 plus floor into minus 5.5. So what you have to do? You have to manually calculate and write a program to check whether your output is correct or not. Okay, and each case, every case, you make two columns. One is manual calculation, another is your program calculation, and see how many you have corrected. Right? Fifth one. Okay, so this is a long program. Try to understand. The logic is very simple. There is a parking garage. Okay, just like we are doing parking in front of a shopping mall or parking in front of a park. Okay, so the parking garage. Okay, $2 is the minimum fee that they are charging, and the minimum first 3 hours. So you can park vehicle, you can pay $2 for 3 hours. Okay, but if you want more hours, if you exceed 3 hours, the garage charges an additional $0.50 per hour for each hour or part thereof in excess of 3 hours. Even if it is 3.5, so you have to charge the minimum one $2 for the first 3 hours. For 0.5, you have to pay for 30 minutes. You have to pay $50. Okay, $0.50. Okay, but the maximum charges for any given 24 hours is $10. Maximum charge you pay up to $10, and that is applicable for 24 hours. Assume that no car parks for longer than 24 hours at a time. Okay, no car is parking more than 24 hours. That is not allowed. That calculates and prints the parking charge of each of 3 customers who parked their cars in the garage yesterday. So just like a billing system, right? You are purchasing a lot of items and final billing is coming. But here it is restricted to 3 customers. Okay. So you should enter the hours parked for each customer. Right? First customer, how many hours? Second customer, how many hours? Third customer, how many hours? So based upon the hours, you have to calculate what is the cost. Your program should print the results in a tabular format. Clear-cut tabular format, you have to print. Other formats are not applicable. And it should calculate and print the total of yesterday's receipt. How many hours these 3 customers parked and what is the total cost. Right? Total earning also you have to specify. The program should use the function calculate charges to determine charge for each customer. Customer 1. And your output should look like this one. You can see car 1 parked for 1.5. For first 3 hours $2, so it is 2. Car 2 parked for 4 hours. For first 3 hours it is $2. For next 1 hour it is 0.50. So it is 2.50. For car 3 it is 24 hours. For 24 hours maximum charge is 10. And some of these car are earned, right? For the parking charge earned, that is 14.50. Right? In this manner, you have to present the output. The next one, you have to write a function. The function name is integer power, which takes 2 parameters. One is base, another is exponent. Okay, and that returns base to the power exponent. Already power function is there, but you have to take a programmer defined function that is integer power, and which takes 2 parameters, that is base and exponent. Accordingly, you have to calculate. Like here I have mentioned integer power 3, 4. Okay, assume that exponent is a positive and non-zero integer and base is an integer. Obviously, right? And do not use any math library function. You should not use power function or C math header file. It is not allowed, right? Next is define a function hypotenuse, right? that calculates the hypotenuse of a right triangle when the other two right sides are given. So you know Pythagoras theorem, right? A square plus B square is equal to C square. So you are given with the two sides of a right triangle. So you have to determine the third side, that is C, which is called as hypotenuse. Right? How you are going to calculate? C is nothing but root over of A square plus B square. Like here you can see I have specified three triangles. First triangle side is 3, one side is 3 and the side is 4. Let it be in centimeter. Okay, and you have to determine the C value. Second one and side 2, you have to determine next one. Third case, it is 8 and 15. You have to determine the third one. Right? So the function should take two double argument, like you have seen in the three cases, and returns a hypotenuse as a double. So use this function in a program to determine the C value for each of the triangles shown below. So you have to check, right, and print the values. Next one is write a program that inputs a series of integers. You have to give a set of inputs at the same time. And what it is going to do, it is going to check whether the given list of input, okay, it will going to take how many are even number. So you have to define a function is even, which uses the modulus operator to determine whether an integer is even or not. Right? So the function should take an integer argument even. But if the integer is not even, then it is going to print false. But what is the new thing? The new thing is that you should not give one input. You should give a list of input. Right? Next one is write a function that takes the time as 3 integer argument. You have to specify the hour, you have to specify the minutes, you have to specify the second. Then first task is it is going to return you the number of seconds. Okay, since the last time the clock stopped 12, it will calculate seconds and use this function to calculate the amount of time in second between two different times. You can give 2 times and it will show you what is the difference between these 2 times in seconds. Okay, so that is within a 12-hour cycle of the clock. For that you have to write a program. Next one is write a recursive function. Name is power. It takes 2 arguments, base and exponent, and it will return you base to the power exponent, which I already told you that power of 3 for you, it will calculate 3 into 3 into 3 into 3. But previous case you try through non-recursive way or through iteration. But this case you have to do by the help of recursion. Like in this case, if I'll tell base to the power exponent, you have to calculate, that is nothing but base into base to the power exponent minus 1. And in order to find base to the power exponent minus 1, again you have to go for base into base to exponent to the power minus 2. Like that you have to iterate, right? And the terminating condition is when you reach to base to the power 1 is equal to base. Until unless you reach to that, you have to go on iterating this particular function, right? The last program is write a complete C++ program. 2 alternate functions. Okay? 2 alternate function is nothing but triple by value. Which what it is doing? It is following the logic of call by value. So it will pass a copy of count by value and triples the copy. Means if you give 2, then it is going to do 2 into 2 into 2. Triples the variable count and returns the new value. But in the B case, second case, what you have to do? You have to define a function that is triple by reference. So here you are not giving the copy of value. What you have to do? You have to pass the count by reference. I told you in the morning. What is the meaning of INT? Address of count. Okay. So in the first case, it is called by value. Second case, it is called by reference. Or pass by value, pass by reference. Okay, and you have to give triple by reference. Okay, it is also returning you the triple of the reference, but first case you are passing the value and see what is the change in that two. Call by value and call by reference.